Okay, today's lesson is about order of operations and evaluating expressions. We're going to be talking about how to simplify expressions involving exponents and how to use order of operations. I'm sure you're already familiar with order of operations and PEMDAS. Please excuse my dear Aunt Sally, however you guys look at it. But we're going to also delve into some exponents. So what is an exponent? What is a power? What is the base? We're going to look at some powers, and I'm hoping that you'll be able to use powers in order to help you represent repeated multiplication. For example, you don't want to write 2 times 2 times 2 times 2 times 2. Instead, you would want to write 2 to the whatever power, however many times I said that. So what we're talking about is a power, and a power has two parts, one being the base and one being the exponent. We've got the base and the exponent. So what these are, the exponent tells you how many times to use the base as a factor. So the exponent tells you how many times to use the base as a factor. So in English, what that means, let's say I've got 3 to the second power. This is my exponent. This part right here is the base. So the exponent tells me how many times I have to use the base. So since there's 2, that tells me I have to use the base 2 times. 3 times 3. I use the base 2 times and I get, of course, 9. So 3 squared is 9. If I had 4 to the third power, this 3 tells me how many times I have the 4. So that's 4 times 4 times 4. So 4 to the third power is the same as 4 times 4 times 4. Okay, so simplifying powers. What we want to do is think about what the exponent indicates. If I have 10 to the 7th power, what does that 7 indicate? That I have 10 7 times. So that's equal to 10 times 10 times 10 times 10 times 10 times 10. Let me count. 1, 2, 3, 4, 5, 6, 7. 10 7 times. And the same thing is true in this problem, even though it's a decimal. If it was a fraction, it would be the same thing. 0.2 to the 5th power, this 5 tells me that I need to write that 0.2 5 times. So now I've got it. 3, 4, 5. Essentially, I'm timesing 0.2 by itself 5 times. Okay, so what I want you to do is pause the video and go ahead and try this. What is the simplified form of the expression 3 to the 4th power, 2/3 to the 3rd power, and 0.5 to the 3rd power? Okay, when you simplify them, you will find the answers to be 81, 8 over 27, and 0.125. I rewrote 3 to the 4th as 3 times 3 times 3 times 3, and it's asking for the simplified form, so I go ahead and multiply that out, and I get 81. Did the same thing with the 2/3, wrote it out 3 times, and then simplified it and got 8 over 27. Do the same thing with this one, 0.5 3 times. I multiply it out 3 times, and I get 0.125. So when there is more than one operation, what you have to do is make sure that you perform the operations in the correct order. So for example, in this first problem up here, I've got addition and I've got multiplication. So you guys know from past math classes that you are going to multiply first, then add. And let's look at why. If I multiply first, I get 15. Then add the 2, I get 17. If I just went in the order that it was written, I would say 2 plus 3 first is 5, then 5 times 5 is 25. So obviously I don't get the same answer both times. So this is not correct. This is the correct way to do it. So we do multiplication first, then the addition. And I'll put this up here. Parentheses, exponents, multiplication or division, whichever comes first, reading left to right, and then addition and subtraction, whichever comes first, reading left to right. So let's look at some more examples. There are a few misconceptions with PEMDAS. A lot of people want to say parentheses first, then exponents, then I multiply, because that's the way that we say it. But it doesn't matter if you multiply or if you divide first. If it depends on where it is in the problem. So if it's multiplication comes first when you're reading the problem from left to right, then yes, you multiply first. But if division comes before the multiplication, then you will have to divide first. And the same is true with addition and subtraction. It's whichever one comes first when you're reading the problem left to right. So let's try some. I want you to go ahead and pause the video and see if you guys can do these problems, and then check it and see what I came up with. So I'll give you a second to try it. Pause the video. Okay, let's look at these problems. I have them worked out for you. I kind of moved them around so that there was a little bit more space. But PEMDAS, parentheses first. I jumped to my parentheses and did the 6 minus 2 first and got 4. Then I just copied everything else down. 4 cubed divided by 2. Please excuse my dear Aunt Sally. Next comes exponents. So I have to take care of this third power here. So 4 to the third power is 64. 4 times 4 times 4 is 64. Then I did the 64 divided by 2, and I got 32. Now this one down here is a little bit tricky problem, because what a lot of people forget is that this fraction bar kind of acts as a grouping symbol. When I see a bunch of things over top of something, I just kind of think of there being grouping symbols in there. So what I need to do first is take care of my exponent right here. 2 to the 4th power is the same as 2 times 2 times 2 times 2, which is 16. And then I just write everything else down. 16 minus 1 all over 5. So think of this as being grouped together. It's a grouping symbol. It's all over 5. So I'm going to do what's up here on top first. 16 minus 1 is 15. Then I can go ahead and do my division. And you're probably thinking, well, you said to do multiplying or dividing before I do add or subtracting. So why are we subtracting this before we divide? And it's because this fraction bar acts as a grouping symbol. So it's like what's inside of here is, this is still parentheses. So we have to do parentheses before we do multiplication or division. That sometimes throws people off a little bit. So remember, if there's a big fraction bar and there's a bunch of things above it, to think of that as a grouping symbol. Okay, so it's your turn. Go ahead and pause the video and try to find the simplified form of each expression. Okay, so in this first one, I jumped ahead and did the exponent first. 4 squared is 16. Then I had 5 times 7 minus 16 divided by 2. So I went ahead and did the 5 times 7 first and got 35. Then that 16 divided by 2 is 8. Then last of all, I can subtract. That 35 minus 8 gives you the 27. Part B, you just skip ahead, do the 25 divided by 5 first, and I get 5. Then I have 12 minus 5, which is 7. Part C, once again, I've got this big fraction bar here. We're thinking of it as grouping symbols. So I have what's on top and what's on bottom to take care of. Jump ahead first and do that 3 to the 4th power, which is 81. 4 plus 81 gives me the 85. On the bottom, I have 7 minus 2, which is 5. So I'm going to do that 85 divided by 5, and I do get 17. So the last part said, how does a fraction bar act as a grouping symbol? There should be a question mark there. And explain that. So the way that it acts as a grouping symbol is the fact that we have to take care of what's on top and what's on bottom before we can actually divide. We simplify the numerator, the top, some important vocabulary. And then you simplify the denominator. And then you divide them. So that's how it acts as a grouping symbol. Okay. Okay, it says evaluating algebraic expressions. We want to know what is the value of these expressions if x is equal to 5 and y is equal to 2. And I have this little star on here because this happens a lot. When I have, like, in this part down here, the x and y side by side, be careful when you plug those values in that you don't put it as 52, that you actually remember that this is x times y. So when I plug it in, I'm going to plug it in as 5 times 2. Then square it. Then divided by 5 times 2 again. Okay, so I just plugged it in so far. It told me x was equal to 5. So wherever I have an x, I'm going to replace it with a 5. So I've got 5 squared plus 5 minus 12, and the same thing's true for y. Wherever I have a y, I want to replace it with what y is the same as. So y is 2, I have 2 squared. Now we have it simplified so that we've wrote it out, so now we can actually simplify it. We know to do exponents first. So I've got 25 plus 5 minus 12 divided by exponents 4. Okay, then I know to do division next. So 12 divided by 4 is 3. So I've got 25 plus 5 minus 3. 25 plus 5 is 30. 30 minus 3 is 27. So our answer is 27. Okay. And then the next one, we're going to go ahead and do parentheses first. So 5 times 2 is 10. So I have 10 squared divided by 10. 10 squared is the same as 10 times 10. We know 10 times 10 is 100. 100 divided by 10 is 10. So the correct answer is 10. Okay, so what is the value of each expression when a equals 3 and b equals 4 in a minus b? So this is a little bit more involved. We've got to work a little bit harder to get to the answer. That doesn't mean it's more difficult and you can't do it, so give up now. It means that you've got to think a little bit harder and put a little bit more effort into it. So we're going to color code just to kind of help. We're solving a here first. And it says that a equals 3 and b equals 4. So we're going to plug that in. 3, and in place of the b, I'm putting the value of 4. Minus, in place of a, I'm putting the value of 3. And don't forget to square it. Okay, so for b, let's kind of color coordinate it. We're doing 2, and in place of b, I have 4, square it, minus 7 times, in place of a, I'm going to replace it with a 3. Okay, so now let's go ahead and simplify. We know to do parentheses first. There's really nothing to simplify in the parentheses, so I'm going to skip ahead to the exponents. So I have 3 times 4 minus 9. Well, we know 3 times 4 is 12. 12 take away 9 would give me 3. Okay, part B says to do parentheses first, but there's nothing to simplify inside the parentheses, so I'm going to go ahead and do the exponents. So I've got 2 times 16 minus 7 times 3. Go ahead and do my multiplication. 32 minus 21. So 32 minus 21 is what? 9, 10, 11. So now what we have to do is this whole a minus b. So I take my answer from a, which is 3, and I subtract from it my answer from b, which is 11. And 3 take away 11 is negative 8. So the answer to this problem is negative 8. And now we're going to look at a real-world application. I want to know, what is an expression for spending money you have left after depositing 2/5 of your wages in savings? And evaluate the expression for weekly wages of 40, 50, 75, and 100. So let's think about what this is asking here. Saying, we're wanting an expression for how much money you have left if you've deposited 2/5 of, remember yesterday we talked about the word of means multiply. So of, we're multiplying 2/5 of. Okay, so I got interrupted on that recording, so I'm not exactly sure where I left off, but we'll go through this problem again real quick. It says, what is an expression for the spending money you have left after depositing 2/5 of your wages in savings? So to begin with, you have a certain amount of money that you make. Then you take 2/5 of that. Remember, we talked about yesterday, of means to multiply. So you take 2/5 of that wage and you are getting rid of it. You're depositing it into a savings account, and then they want to know how much money you have left afterwards. So I set up some equations here. Let me do it this way first. The wages that I made, and then I subtract 2/5 of. Of means to multiply. So I take 2/5 and multiply it by the amount that I make, and that's going to give me my total. I went ahead and computed this for all of those, and that gives me how much money I have left for spending after I've deposited 2/5 of my wage. If I made $40 and I deposited 2/5 of that, that means I deposited $16. Then I take the 40 and subtract 16 and I get 24. And that's what we did for all of those. And that's how I came up with those numbers.